we can use a potato to generate electrical power. You don't believe me? Come with me to the studio. I'll show you how. Hi there, I am Charlene, and with me you will learn the fundas behind physics and the tricks behind scoring those crucial marks. Have you ever thought what our lives would be without electricity? Take me for example. I am practically driven by electricity. My AC, my cell phone, my watch, my laptop, and all my music. What would I be without these? And what good will they be without electricity? Even the studio is lit up by electricity. And for that matter, the television you're watching me on also runs on electricity. Fascinating, isn't it? And that's exactly what's in this episode on current and voltage. Today we talk about electric current as rate of flow of charge, potential difference as the driving force which does work on the charges in a circuit, circuit diagrams and various electric circuit components, and of course we are going to have our exam decoded section. I guess we all agree that electric current is an integral part of our modern lives, and it would be rather difficult, if not impossible, to do without it today. But have you ever tried to understand the theory behind electric current? Let me begin with an interesting and simple-looking experimental demonstration. Here we have three things: a small electric bulb, a single connecting wire, and a single cell. I happen to give these things to a few of my students and ask them to light the bulb. The only condition being they cannot break the wire. These were the various connections that they came up with. A, B, C. Now, can you as a smart learner suggest what's wrong with these arrangements? Why were they not able to light a simple bulb? I see a problem in all the three arrangements. And if I address the problem, then ideally I should be able to light the bulb. Let me show you how I would have done that. The circuit now is complete. The charges here get to move from one terminal of the battery to the other. Hence, the bulb glows. Now let's do some introspection here. What makes the bulb glow? What role does the battery here play? And what is the importance of the circuit being complete? Let's take these queries one by one. Let's begin with what is electric current? Whenever charges flow through a wire at a regular rate, there is electric current. Electric current is a physical quantity which is defined as the rate of flow of charge. That is, I is equal to Q by T. If charge is measured in coulombs and time in seconds, then electric current is measured in amperes, where 1 ampere is equal to 1 coulomb per second. So before we move on, here's a question from our young viewer.
Charlene, I have been hearing that electricity and current flows, but what is the direction in which it flows?
That's a super question. Our friend wants to know exactly what is the direction in which current flows. Now, electric current is due to the flow of electrons carrying negative charges. However, conventionally, the direction of electric current through a conductor is the same as the direction in which the positive charges flow. Hence, the direction of electric current through a conductor is opposite to the direction of the flow of electrons in that conductor. I hope you got that. Please pay attention to these definitions and explanations because they will form the foundation of all further learnings in the chapter on electricity. Now let's move on and look at what causes electric current to flow. We all know that all metal wires have free electrons which are available for free movement along the length of the conductor. But does that mean current is always flowing through the wire on its own? Or do we need an external agency to make the electrons flow? Well, of course, like you and me, even the free electrons need something that prompts them to move. That is, flow across a conductor. Actually, it requires a constant work to be done to move the charges effectively from one end to another end. This work is done by an external agency which we call a battery or a cell. Now the cell or battery, when connected across a wire, drives the charge carriers like electrons from one end to another. This driving force is due to the difference in voltage that the battery creates at the two ends of a wire. As long as this voltage difference is maintained, there will be constant electric current through the wire. Well, it's time now to take a short break, but before we go, can you tell me that how many electrons flow in a second so that 1 ampere of current is generated? I'll catch you on the other side of the break with the answer.
Hello viewers, welcome to Beyond Breaking News, where the news is of the people,
For the people, but
By the youth.
by the youth.
by the youth.
You can watch our bold and brainy brigade of young journals on Beyond Breaking News only on Toppers.
I got it some flowers for my favorite teacher. I mean you, Miss Marks.
That's so lovely, Snail. And look at these. What perfection. The lovely symmetry. Rotational symmetry, actually. And at some angles, it retains as it is.
Miss Marks, what are you talking about? Rotation? Symmetry? Angles?
Welcome back. Before the break, I asked you that how many electrons should flow through a conductor in 1 second to generate 1 ampere of current. Now, it has been found out by experiment that each electron carries a charge of 1.6 into 10 to the power minus 19 coulomb. So, using unitary method, we can say 1 coulomb of charge is equal to 1 divided by 1.6 into 10 to the power minus 19. Solving that, we get 1 coulomb is equal to the charge on 6.25 into 10 to the power 18 electrons. That means if 6.25 into 10 to the power 18 electrons pass through a given cross-section of wire in a second, the electric current through the wire will be equal to 1 ampere. I guess now we know enough to try and resolve our power woes. Remember how I ran out of batteries while shopping? Now the question was whether a potato could be used to generate power. A potato. Well, the answer is yes. Though there's not much you can do with the amount of electric current, but it can be surely measured on a multimeter. So here is a potato. And all I have done is inserted a galvanized nail, that is a zinc-coated nail, and a copper nail. Now, using a multimeter, I measure if there's any voltage difference between the two. Eureka! Well, the meter shows deflection, and that means there is some voltage difference between the two nails. Well, this is not some kitchen magic, but we have actually created what can be called a very primitive battery, in which the copper nail acts as cathode and the zinc nail as an anode. Now a reaction occurs inside the potato because the fluids inside the potato act as an electrolyte. This leads to a potential difference or a difference in concentration of positive and negative ions at the two electrodes, and a flow of electrons is established through the wire to try and balance out this difference. And now we know that a voltage difference can drive the electrons from an electrode which has excess electrons towards the electrode which is deficient in electrons. This flow of electrons is, well, electricity, and hence the multimeter shows it. Our humble potato experiment has helped us establish that whenever there is a difference in concentration of ions, positive and negative charges at electrodes, flow of electrons is established, which constitutes electric current. However, there are a few conditions that must be met before the current flows. We have already established that the presence of a potential difference is one of the essential conditions. Circuit not complete or being open means no flow of electrons. Circuit complete or closed means a flow of electrons and hence electric current. And this is what the switches in your homes do. When you press them, you break or make the circuit of the electrical appliance. Our next question was posted on the web by one of our viewers who wants to know whether we can quantify battery voltage. Now what say you? Well, yes, we can. Voltage difference between the two terminals is defined as work done per unit charge by the battery in moving charge from one terminal to another. That is, V is equal to W by Q. It is obvious now that unit of voltage difference will be unit of work divided by unit of charge. That is, joule per coulomb. It is also denoted as volt. So we can say a work of 1 joule done to move a charge of 1 coulomb results in a voltage difference of 1 volt. Well, if you want to post your own queries or read what others have posted, don't forget to log on to our website, topperlearning.com. Let me take you through an analogy so as to illustrate the fact that the battery will ensure driving the current through the circuit at a constant rate and continuously. A water pump in a locality stores water at a height. The water inside the water storehouse has higher potential energy. The pipelines originating from the water storehouse distribute the water to all the houses at the ground level. This flow of water through the pipelines continues till A, the water is there in the water storehouse. B, there is a constant replenishment of water inside the water pump. How does the latter happen? That is the role of the water pump. It is water pump on the ground level that constantly pumps water from the reservoir at the ground level up to the water storehouse. The work is done on the water by the electrical energy as it gets lifted up to the water storehouse. So, it is the water pump that ensures that water is constantly replenished in the storehouse. This helps maintain the pressure difference across the storehouse and the ground level. And the difference in the level of water level in the storehouse with respect to the ground ensures that water always flows from the storehouse onto the ground level at a constant rate. In this analogy, water flow corresponds to flow of charge carriers in a conductor. Pipelines correspond to the electric wire through which the charge carriers flow. Water pump corresponds to the battery or the power source. The battery source is hence responsible for driving the charge carriers through the wire. This results in electric current through the wire. Battery does the work required to move the charges through the wire from one end to the other. Maintaining constant voltage difference between the two ends of the conductor is also done by the battery. This ensures that electric current through the wire stays constant. I think by now you're thorough with electric current and the role of battery to generate current through a conductor. But have you ever wondered why our batteries run out of power after prolonged use? As it happened with me at the grocery store. It is simple. There is a decline in electric current because the battery is unable to maintain the constant potential difference. The electric current begins to decline as the voltage difference across the conductor begins to decrease. The battery is losing its capacity to keep driving the charges at the same rate as it started with. Remember, the essential condition I told you for current to flow through a circuit. Now then, there are a few components that you will come across while studying circuits, like a key and a resistor. A key in our case here is more like a switch. It allows you to switch on or off an electric circuit rather than the lock-unlock door kind of a key. While a resistor, as the name suggests, resists the flow of current through a conductor. Hence, it determines how much current will flow through the circuit. Higher resistance will reduce the total current in the circuit for an applied voltage difference. On the other hand, lower resistance will ensure large electrical current through the circuit. Well, it's time for a break now, and when we come back, we will find ways to score those marks with Exam Decoded.
Looking to boost your grades and ace those exams? Now you've got plenty of choices at topperlearning.com. Be your own guide. Grade yourself on our online tests. Get expert help on difficult questions. Find answers to the trickiest problems and solutions to previous year's question papers. All this at one place, topperlearning.com. Log on to the internet. Log on to success. Be a topper. Get ahead.
Do you want a career that will take you places? If yes, then this is the show for you. You may have the heart, but do you have the touch? What are the new options available to you out there? And what is the future like? What is it that will differentiate you from the average? We'll explore all these questions and more. Don't forget to watch CareerWise, your roadmap to success.
Hi there. Great to see you again. Before we move on, let's take a quick look at what we have learned so far. Number 1. Electric current is the rate of flow of charge. Number 2, battery provides the driving force required to move the charges along the wire from one terminal to another. Number 3, the constant voltage difference between the two terminals of a wire maintains the constant electric current through the wire. Number 4, electric current is measured in terms of amperes, where 1 ampere is equal to 1 coulomb per second. And lastly, number 5, the voltage difference is measured in terms of volts, where 1 volt is equal to 1 joule per coulomb. And now let's tweak it up a notch and crack those exam questions with Exam Decoded. Welcome to Exam Decoded, the segment where you not only test your conceptual grasp of the subject, but you also learn what to expect by looking at exam trends. Not just that, we also help you identify and polish your abilities to crack this topic in the exams. And of course, our expert will also give you precious tips on how to approach your exams and what to look out for. To begin with, I will be asking you 5 questions to test your understanding of this topic. The answers are either multiple choice or true or false type. So get your pens and paper ready and let's get cracking with our rapid fire round. Here's the first one. Electric current in a metallic conductor is due to the movement of A. Ions, B. Protons, C. Electrons, D. Amperes. The answer is C. As we know that flow of electrons causes flow of electric current. Now question number 2. The direction of current is A. Same as the direction of motion of positive charges, B. Same as the direction of motion of negative charges, C. Same as the direction of motion of neutrons, D. Always from left to right of the wire. I know you got this one right too. The answer is A. But be careful when attempting such questions and always remember that the direction of current is the same as the direction of positive charges and opposite to that of negative charges or electrons. Well, we move on to the next question. Number 3. No current flows between two charged bodies when connected if they have the same A. capacity, B. potential, C. quantity of charge, and D. charge to potential ratio. Tricky one, that is. Well, the answer is B. Current flows through a conductor only when there is a potential difference between its two ends. Question number 4. A charge is taken from point A to point B. The work done per unit charge in the process is called A. the voltage at A, B. the voltage at B, C. the voltage difference between A and B, and D. the current from A to B. Well, this one was simple. The answer is C, and we know that from the definition of potential difference. And here's the last one. Question number 5. What is represented by joule per coulomb? A. ampere, B. volt, C. watt, and D. ohm. The answer is B. volt, as potential difference is work done per charge. Now that was great. Here is the scorecard. How much did you get? If you got all of them right, you are a high flyer. Congratulations, well done. If you scored 3 or 4, you rank yourself as an achiever. That's good too. If you scored any less than 3, well, then you're a learner. But don't worry, with regular practice, you too will be able to become a high flyer soon. And logging on to our website, topperlearning.com, will help you further making a better scorecard. Now, let us see how important this episode is from an examination point of view. Now, this episode lays the basic foundations of the fundamental concepts of current and voltage, which form the basis of understanding of Ohm's law and its applications to various electric circuits. The questions from this topic will be designed to test your knowledge skills and numerical ability. Well, now that you know the weightage and the type of questions that you will be asked in your exams, here are 2 questions and what we think should be an ideal answer to them. Here's the first question based on knowledge skills. Give 2 conditions needed for the flow of current. A question like this usually carries 2 marks. And a good way to answer this question could possibly be, flow of current in a wire is produced and maintained only if A. there is a potential difference generated between the 2 ends of the wire, B. a constant potential difference is maintained across the 2 ends of the wire. Getting both conditions right will get you both the marks. Now let's take a look at the second question aimed at testing your numerical ability. An electric appliance draws a current of 0.4 amperes when the voltage is 200 volts. Calculate the amount of charge flowing through it in 1 hour. Now this question was for 2 marks and appeared in CBSE examinations in 2004. Here, the electrical appliance behaves as an external load through which the battery source of 200 volts has to drive the charge, let's say Q. We are required to find the charge that needs to flow through this external appliance over a time interval of 1 hour, that is 60 into 60 seconds, such that it results in an electric current of 0.4 amperes. Now we know that electric current is equal to charge upon time taken. Writing till this formula will get you 1 mark. Substituting and calculating the final value as follows will fetch you the remaining 1 mark. 0.4 amperes is equal to Q by 3600. This implies charge Q is equal to 0.4 into 3600, that's equal to 1440 coulombs. Now let's quickly go to an exam expert and find out how to approach the exams and what to look out for.
For relating current and voltage, Ohm, the scientist Ohm gave this law. Ohm's law is V is equal to IR. That is, the current and potential difference are directly proportional to each other. So it's important to learn what is Ohm's law, what is its formula, and how it is used and how it is verified. So there's a simple circuit diagram which is given in the books, and even in practicals you connect that circuit and verify the Ohm's law. So there you see that as you keep on increasing the voltage, the current also keeps on increasing for a constant resistance. And you can also calculate R, the resistance, by this, by the ratio of V and I.
So that's all for now. But don't forget to log on to our website, topperlearning.com. But before I leave, here's some food for thought, as usual. Argon and neon are gases and don't normally conduct electricity. What effect causes them to conduct electricity in the gas-filled tube lights? While you think about it, I will take leave. And don't forget, knowledge is light. So, open your doors of perception.